All right, so today I'm going to be reviewing the comparative testing of 6 antigen-based malaria vaccine candidates directed towards the Morazocyte stage Plasmodium falciparum, which is a strand of malaria. So within this journal, there were honestly several different research questions. The main questions, however, are these that are presented. So their overall goal was to create a systemic approach to selecting the most advantageous antigen for a malaria vaccine based on immunogenicity and different assay analysis. So the first question was, how do different antigen combinations of the baculovirus and Pichia and antigen fusions, so AMA1 fused to MSP119, and then in addition, antigen recombinants compare quantitatively in terms of inhibition and induction of the immune response. The second question was, which antigen candidate produced antibodies that have the greatest ability to inhibit parasite growth in vitro against different strains? And then another huge research question was, can various in vitro assays, so ELISA, the GIAs, etc., serve as a reliable analysis for vaccine antigen selection? So, although these are great questions, there was a lot of research gaps that were identified. So there's a lack of translation to in vivo, just in the assays that they used. So it used a lot of in vitro assays that quantified data, such as like the parasite growth inhibition and antibody immune response. However, there was a lack in various research and in their research that showed the correlation between in vitro and in vivo results. And then the second one is just strain dependency and lack of overall understanding of malaria. So in the study, along with other studies, very few strains are actually used to identify vaccines. However, there's a plethora of different strains of malaria, so that was a constraint. The next constraint would just be a lack of understanding in which mechanisms promote inhibition through the use of antibodies. So greater understanding of those mechanisms could correlate to better inhibition of those mechanisms. So different hypotheses. So they hypothesized that antibodies produced to inhibit MSP119 and AMA1 proteins will show different efficiency when inhibiting the parasite growth. They also hypothesized that different fusions and combinations of the antigens and antibodies would lead to a stronger immune response and therefore greater inhibitory effects of the malaria parasite. And lastly, they hypothesized that different antigens would show varying levels of antibody response and parasite growth inhibition, which would further lead to quantification of which candidate would be most effective as a malaria vaccine. So their major findings, so they found that MSP119 antigen induced superior levels of parasite-specific antibodies compared to that of the other 5 antigen formulations. They found that antibodies induced by the baculovirus MSP119 demonstrated higher levels of inhibitory effects on the parasite growth. And then Pichia MSP119 antigens were less effective, whereas the AMA1 containing antigens were about intermediate inhibition effect. Then they also found that the genetic fusions of AMA1 and MSP119 increased immunogenicity for MSP119 without reducing anti-AMA1 response. So they reduced antibody levels against MSP119. All right, so here in the graph, what we are looking at is actually quantification of 2 different mechanisms and assays that depict inhibition. So we have the LDH BP RC shown in the dark squares, filled in squares, and then flow cytometry in the hollowed out squares. So what they're trying to do here is just quantify which method is best at discovering the inhibition of the malaria. So we can clearly see here that the flow cytometry, which is measuring the amount of the presence of antibodies and the percent growth inhibition